Set yourself up for an interstellar stunner. In light of the fact that, as per a gathering of researchers, Betelgeuse, that entrancing red very monster embellishing Orion's shoulder, has proactively detonated. That's right, you heard that right. We are not kidding. Inside the following 10 years or a couple of many years, its splendid result will enlighten the night sky. But how did researchers arrive at this guarantee? Should we be concerned? Might the James Webb Space Telescope catch the remainders of scarab juice? Today we're diving profound into all the most recent subtleties. One of the most noticeable stars in the night sky in the northern side of the equator during winter is the red very monster star, Betelgeuse. It's among the modest bunch of stars that sparkle brilliantly enough for us that we can actually see its ruddy orange tone with the unaided eye. Creepy crawly juice is typically the 10th most splendid star in the night sky. However, as you may definitely realize, it's forever been known to fluctuate in splendor. Part of the justification for this is that scarab juice is by no means your regular star, due to its gigantic size. In the event that we were somehow able to supplant scarab with our own little sun, it would stretch out the entire way to the space rock belt and have a mass of an astounding multiple times that of the sun. It may come as a shock, however, scarab juice is quite youthful for a star, with an age assessed to associate with 8 to 10 million years. In examination, our own sun is a lot more seasoned, with an expected period of around 4.6 billion years. This is on the grounds that very monster stars like this consume quickly through their atomic fuel and go cosmic explosion somewhat rapidly on geological timescales. This additionally implies they develop quickly, and Betelgeuse may, in reality, have done that right previously humankind's eyes. To grasp how researchers reached the resolution that Betelgeuse had previously detonated, it's critical to dive into the setting. Later that we should dive into all the proof. Come, my companion, and let me take you on a captivating excursion to disentangle the conundrum of Betelgeuse. The story starts around the 2nd century BC, where Chinese space experts made a significant perception that Betelgeuse showed a particular yellow tint. Fast forward to the center of the 2nd century AD, and the Greek-Roman cosmologist Ptolemy portrayed it as orangish or reddish, equivalent to how it shows up today. Likewise, archaic onlookers in the Middle East noticed a comparative shading. The inquiry emerges about how colors were named or seen in the past. Yet, for this situation, there is an actual chance that Betelgeuse went through a variety change inside a couple of hundred years. It is conceivable that Chinese cosmologists observed insect juice during its yellow very Goliath stage, and over a few centuries it changed into the red very Goliath stage. Given that people, by our temperament, are night sky watchers, you need to consider the number of individuals across the globe that could see the star, saw the change, but left no records. After all, changes to a star like that likely accompanied a wide range of darkening and lighting up occasions that aren't recorded. Imagine them facing up at the night sky and saying, "Hey, didn't that star used to be brighter?" And that is precisely accurate. Things been happening right now. Betelgeuse is a variable star, but it appears to adjust to some cyclic behaving. Starting in December 2019, scarab juice's brightness unusually plunged by a huge amount, which was apparently perceptible to the unaided eye. For those used to looking at the star, it was not its expected self until mid-2020. Over time, it recovered, and one theory was that some of these cycles had coincided, making for a particularly deep dip in brightness. However, the observations made by the Hubble Space Telescope showed something rather unconventional. It appeared that scarab juice had expelled a massive amount of burning material into space, forming a huge dust cloud. This dust cloud, in turn, darkened a significant part of the star's light when seen from our viewpoint. The change was quite astonishing. Betelgeuse, once counted among the 10 most brilliant stars in the night sky, faded to where it ranked lower than the 20th brightest. It was truly bewildering to observe its obscurity in comparison with its neighboring star, Aldebaran, which holds the 14th position regarding brightness. Fortunately, Betelgeuse gave signs of improvement, yet its surprising behaving did not stop. In fact, it is currently showing a state far stranger than simple darkening. Over the course of recent months, Betelgeuse has undergone a dramatic increase in brightness, surpassing its expected glow by a staggering 50%. This puzzling situation is quite unsettling for a star that is known for its changes. The dimming events could be caused by dust or coinciding cycles, or perhaps the star developed huge sunspots. However, a significant increase in brightness is a different matter altogether. Although it could be associated with the previous event when Betelgeuse expelled material in the event of 2019, it probably caused a significant disturbance in the star's plasma flow. The recent behavior we observe could be considered an aftershock of that discharge. But what lies behind this peculiar behaving, surpassing the star's usual variability? One moderate theory that has been widely discussed is that Betelgeuse is approaching the supernova stage. While moderate estimates still suggest that the star is roughly 100,000 years from today's supernova event, we will give evidence to scrutinize this idea further and show that it has proactively played out. So, what is the evidence? According to a groundbreaking recent scientific paper by Hakio and partners of Tohoku University in Japan, Betelgeuse has proactively gone through a supernova blast, and we may be seeing the repercussions of this astronomical event in no less than 10 years or a couple of decades from now. Yes, that's right, that's astounding. As the last observed supernova in our universe was Kepler's supernova, which was as far back as the 1600s. Through a careful examination of Betelgeuse's fluctuation patterns, the researchers have identified 4 distinct periodic changes occurring at time spans of 2,200, 420, 230, and 185 days. While the origin of the longest period remains unclear, it is speculated to be the central period, with the shorter spans possibly serving as echoes. The scientists propose a model suggesting that Betelgeuse is in a late stage of carbon burning, implying that it might be on the brink of a supernova blast, positioning it as a prominent candidate for the next expected supernova event within our Milky Way galaxy. When it comes to unraveling the mystery surrounding Betelgeuse, there's a bit of a puzzle. You see, there are some conflicting observations regarding the ejection of materials and the star's subsequent recovery. The general consensus leans towards a mass ejection event, something not entirely unheard of for other types of stars, albeit on a smaller scale compared to our own Sunday. However, here is the twist: supernovae are a real thing too. We actually witnessed one in a neighboring galaxy of the Milky Way back in 1987. So, while it's possible that our estimates for Betelgeuse's blast timing could be off, don't go planning a vacation around it just yet. The tricky part is that Betelgeuse is currently precarious to observe. It has slipped behind the sun and won't be visible in the evening sky until late August. Hence, we're left in the dark about what this enigmatic star is up to. What we do know, however, is that it's defying its usual patterns by brightening. Now here's something interesting. Betelgeuse's enormous size and relatively close proximity, around 650 light-years away, allow us to discern it as more than just a point of light. Most stars are simply too distant, appearing as mere points of light. But with Betelgeuse, we have a rare opportunity to capture direct variations in its light output through photography. So, we not only have a star that might go supernova but also plenty of data to collect, including images, even if they may be somewhat blurry. Now let's imagine the scenario where Betelgeuse actually has indeed gone supernova. How might it look? Firstly, it will be a spectacular sight. But don't worry, it's entirely safe for us here on Earth. You see, Betelgeuse is quite far away, so it won't pose any threat to our planet when it goes supernova. It won't be the brightest object in the sky either. The moon will still surpass it by far, and let's not forget about the sun. However, it would certainly create its own shadows at night and remain visible during the daytime for about a year. Now, here's the interesting part. The supernova would be visible at night for several months, gradually fading away. There might be a brief period where it regains some of its former brightness, but ultimately, it will continue to fade until the recognizable shoulder star in the constellation Orion disappears altogether. While this supernova won't pose any threat to us, it could cause some confusion for certain animals. Some creatures rely on moonlight for navigation, and with an extra bright light overhead creating shadows, it could disrupt their behavior. But that's not all. Astronomy itself would face some challenges. Observing the night sky from Earth during times when the moon is shining brightly can be a bit tricky. A very bright supernova would only complicate matters further. However, many telescopes would likely be more interested in capturing the supernova's brilliance than anything else, even if it means adjusting their observations. Plus, there would be some warning signs before the visible explosion. like detecting neutrinos and gravitational waves, providing astronomers time to prepare their telescopes. Now let's delve into our next question. Has the James Webb Space Telescope, JWST, actually observed the remnants of Betelgeuse? Be sure to share your thoughts on Betelgeuse's supernova blast in the comments. And don't forget to like and subscribe to Beyond Discovery. Now let's continue our story. Well, heads up. Unfortunately, the James Webb Space Telescope has not had the fortunate opportunity to take a look at Betelgeuse. Why? It's all because Betelgeuse is just too darn bright for JWST's liking. You see, JWST was specifically designed to incredibly detect faint objects in the infinity of space. But if it turned its gaze toward Betelgeuse, the star's blinding brightness would completely overwhelm its detectors. Trust me, that's not a situation we want to encounter. To give you some context, Betelgeuse's infrared magnitude is an astounding 4.378, making it about 10 times brighter than the saturation limits of JWST's filters. That's akin to trying to stare at the sun without sunglasses on. It's just plain impractical, my friend. But fear not. While the Webb telescope can't help us in pinpointing when Betelgeuse will go supernova, there are plenty of other observatories eagerly awaiting to capture the cosmic spectacle. These observatories, both on the ground and in space, will be equipped with various instruments and techniques to unravel the mysteries of the supernova blast. Just imagine the excitement of witnessing Betelgeuse go supernova in real time. We would have the opportunity to see this spectacular event unfolding right before us, gathering a treasure trove of scientific data. Once the supernova dims and disappears, our attention would shift to studying the aftermath. An excellent example is the Crab Nebula, a remnant from a supernova that exploded in the 11th century. Back then, if you had a telescope, you wouldn't have seen the cloud as it appears today. It's still visible, evolving and expanding from the site of the blast. Now, what remains after a Type II supernova like the one Betelgeuse is expected to experience depends on the amount of material left behind. It could collapse into a neutron star or, if there's enough material, transform into a black hole. Both scenarios are rare, especially considering Betelgeuse's proximity. If it becomes a neutron star, it would be one of the closest to Earth. And if it becomes a black hole, it would hold the title of the closest one for a long time. However, reaching it would be a truly daunting journey, spanning many light years. We can't say for certain that Betelgeuse is on the verge of a supernova. The star's surface doesn't reveal what's going on deep inside its core at the moment. It's certainly unstable right now, but it could revert to its usual cycles and stay that way for decades or even centuries. Despite being close to a supernova, alternative models suggest that the blast might not happen for many millennia. Ultimately, only time will reveal the true fate of Betelgeuse. This celestial spectacle reminds us that the night sky is constantly changing, and stars are not eternal. While some endure for immense spans of time, the universe continually evolves on both short and long time scales. So, let's continue to marvel at the wonders of the universe and embrace the mysteries that exist and prepare yourself for cosmic disclosure. Betelgeuse, the captivating red supergiant star that sits on Orion's shoulder, could have currently exploded. That's right, scientists believe the celestial giant could have gone supernova, and its brilliant result could illuminate our night sky within the next couple of decades. But how did researchers arrive at this astonishing conclusion? Should we be frightened? Can the James Webb Space Telescope capture Betelgeuse's remnants? Let's dive into these questions and uncover the latest developments. Betelgeuse is one of the most prominent stars in the Northern Hemisphere's winter sky. It's a red supergiant easily recognizable due to its distinct reddish-orange tint visible to the naked eye. Usually, Betelgeuse ranks as the 10th brightest star in the night sky, although its brightness varies. This variability is due to its immense size. If Betelgeuse replaced our Sun, it would extend all the way to the asteroid belt with a mass 20 times greater than that of the Sun. Despite its enormous size, Betelgeuse is relatively young for a star, estimated to be around 8 to 10 million years old compared to our Sun's 4.6 billion years. Very giant stars like Betelgeuse burn through their nuclear fuel quickly and go supernova relatively quickly on geological timescales. This also means they evolve rapidly, and Betelgeuse may indeed have done so right before humanity's eyes. To understand how researchers concluded that Betelgeuse had already exploded, it's crucial to delve into the context. Later on, let's explore all the evidence. Come along, my friend, and let me take you on a captivating journey to unravel the mystery of Betelgeuse. The story begins around the 2nd century BC, when Chinese astronomers made a significant observation that Betelgeuse exhibited a distinct yellow hue. Fast forward to the middle of the 2nd century AD, and the Greco-Roman astronomer Ptolemy described it as orangish or reddish, similar to how it appears today. Likewise, medieval observers in the Middle East noted a similar color. The question arises, how did the stars become aware? Anticipated was have